So 5.2 covers more properties of exponents. I am going to do a little brief refresher of the properties that are in 5.1. So 5.1 covers two rules that deal with exponents. So we have the rule for multiplying exponential expressions. So if you're multiplying things with exponents, the exponents add together. And they have to be the same thing underneath the exponent. So, like if I have x squared and x cubed, those get added. You get x to the fifth. But if it's x squared and y cubed, they have different letters, so you can't add them, and they stay exactly as they are. The dividing exponential expressions is similar, but you subtract instead of adding. So if I have x cubed over x squared, you subtract top to bottom 3 minus 2. So you get x to the first, which is the same thing as x. But if they're different letters, like x cubed y squared, you can't do anything to it because it's just, they're different letters, they don't match. So those are the two rules that are covered in 5.1. There's lots of different types of problems where you combine with different variables and you can have numbers involved, but that's what the two rules that 5.1 focuses on. And those are the main rules that you use when we move on to factoring, is we basically use those two rules. Now in 5.2, there are additional rules that we are going to be, there's two additional rules essentially. We have the power rule for exponents. And the word power also means exponent. So those are sort of interchangeable. So it's basically saying you're taking exponents, you have an exponent on top of an exponent. So if you assume that b is a real number, and it doesn't have to be, you could have a variable underneath there, but m and n represent positive integers, so the exponents are just whole numbers. And then if you have something with an exponent and you add another exponent to it, the exponents multiply. So your exponents get multiplied together. So it's different from when you add exponents. So going back, if you multiply things with exponents, you add the exponents. If you take a power, if you do an exponent on top of an exponent, you multiply. These two rules get confused a lot with people. So I would recommend doing flashcards for these rules or having them on a post-it somewhere that you can constantly look at, because people get confused by these a lot. Now, to sort of explain why this works, let's say I have x squared, and then I have another exponent outside of it. So it's x squared and then x cubed. The outer exponent is saying that we are multiplying x squared 3 times. So that's what that outer exponent says. Now, if you follow the rules of exponents, the one from 5.1, when you multiply these, you add the exponents. So you are basically adding all of these exponents together. So it's x squared plus a 2 plus a 2. And that gives you x to the 6th, which is the same as 2 times 6, or 2 times 3, which gives you 6. So that's why this rule works, is if you wrote it all out, you can see that it matches up. If you multiply those numbers, you will get the correct exponent. So I have 3 examples here, and they kind of go from easy, and then we get harder, as we go, as I like to do. So we have 2 to the 8, and then another exponent on top of that, which is 7. So we multiply those exponents because there's a power and then another power. So that's 2 to the 8 times 7. Now, 8 times 7 is one of those that for some reason I can never remember. So that comes out to 2 to the 56th power. If I did that on my calculator, it's a giant number. It's absolutely giant. So we're going to just leave it like that. But if you are curious, my calculator says 7.205. It's really big. It's times 10 to the 16. That scientific notation, that times 10 to the 16 means that it has basically, if I wrote this not in the scientific notation, it'd be 7. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is how big the number is. It basically has 16 places before the first number. It's giant. So that is one case where we'd want to just leave it as the exponent rather than writing the actual number out because it's just big. So middle example, I wanted to do it with a variable instead of a number. So it's the same thing. We have h to the 6th, and then that whole thing is to the 4th power. So you multiply those. So that's going to be h to the 6th times 4. So 6 times 4 is 24. So that is just h to the 24th power. Now this one on the right is basically it's got to step up. We have z times z cubed and then squared. So we want to simplify inside because we're multiplying. Z, if it has no exponent, you can add an exponent of 1. So we can think of that as z to the 1st times z cubed and then squared. So we can simplify inside. When we multiply those things with z's, you add the exponents. So I'm going to just, normally I just do the addition in my head and I do the multiplication in my head, but I want to write every step here. So we have z and then 1 plus 3. So we're going to get z to the 4th and then to the 2nd. So you simplify inside the parentheses first, just like with the regular order of operations where you do parentheses first. Once we've simplified there, now we're going to apply the rule where you multiply the exponents. So it's going to be z, and then it's going to be 4 times 2, which gets us our final answer of z to the 8. So before I move to the next slide, are there any questions? Okay. Now our next rule is power of a product. And this is actually basically, it applies to the very last example here. So if you have two things in parentheses and then they have an exponent, like a and b are inside the parentheses, they both share the exponent of m, the exponent gets distributed. So that exponent applies to both of them. So I like to think of this as distributing the exponent. So the reason why this rule holds is if I say I have a, b, and let's say that the exponent is 2. So that would mean that we have ab times ab. So all of that is multiplication. So that means I can rearrange the multiplication so that I can have the a's together and the b's together. And that's because multiplication is associative and commutative. So I can rearrange those. Then a times a gives you a squared because you have 2 of them. And then b times b gives you b squared. So that's, you get back to, you can see the rule. you're basically applying that exponent. Everything on the outside, that exponent from the outside applies to the inside. So everything on the inside gets the same exponent. So we call this power of a product. And we could have applied that rule here, where everything on the outside gets the inside. So using that rule here, we would have said that the z gets the square, and then the z cubed also gets a square. So I have my z squared, and then I'd have my z, and with the 3 and then the square, you multiply those using the previous rule, 3 times 2. So that would give us z squared times z to the 6th. And then you can add them, 2 plus 6, because they're multiplied, and you get the same answer, z to the 8. So when we're simplifying things with exponents, there's sometimes more than one way to simplify and get the same answer. So in black was simplify the inside first and then applying the power rule. In blue, we did the product of a power rule first, then simplified from there. So I'm going to show how this rule applies here for these 3 examples. So on the left, I have 4y and then the 3 on the outside. So that exponent gets applied to everything on the inside. So we get 4 to the 3rd power and y to the 3rd power. So then 4 to the 3rd power, if you do that on your calculator, that comes out to 64. So we get 64y cubed. Now we have in the middle negative 5 x, y, z, and then that whole thing has an exponent of 2. If there is a negative, you're going to put it with the number there. If there's no number, you would make it a negative 1. But that's going to be negative 5, and then we're going to apply that 2. So that 2 applies to both the negative and the 5. And then it applies onto the x, the y, and the z. So then we have a negative 5 squared. So negative 5 times negative 5 gives you a positive 25. So we get 25 x squared, y squared, z squared. Now on the right, we have w squared z, and then we have an exponent of 7 on the outside. So everything on the inside gets that exponent of the 7. So that w squared, that is applied an exponent of 7. So we're going to write it where that's on the outside. And then the z gets an exponent of 7. So that's using our power of a product rule. Now we need to simplify the w squared and then to the 7th power. So that's where you have 2 exponents there, so they multiply together. So it's going to be w and then 2 times 7, and then our z to the 7th. And 2 times 7 is 14. So you get w 14 z to the 7th. Are there any questions so far? Okay. So that rule is basically can be that same rule that applies when you have things that are multiplied together, also applies if you have a fraction or if they're divided. So we call it power of a quotient. It's basically the same rule. So the exponent on the outside gets distributed to everything on the inside. So I'm going to start with just examples here. So on the left, we have 1 over t, and then that's to the 8th power. So everything on the inside gets that exponent of 8. 1 to the 8th power and t to the 8th power. So 1 to the 8th power is just 1. So this ends up as 1 over t to the 8th. Now, the middle one here, I threw in a little curveball because of the negative sign. So we have a negative, but we don't have a number. So you're going to treat that as a -1 and then a w, and then you can put a z. So you can just stick that negative on top with the variable that you have there. If you had a number on top, you can stick that negative up there. But we're going to just put a -1 so that we have an actual number. So we're going to use the rule where you distribute your exponent to the top and the bottom. So our top is -1w, so that's going to get an exponent of 7. And then our bottom, the denominator, is z, and that has an exponent of 7. So that's using the quotient, power of a quotient rule. Now on top, we want to simplify further by the product of a power of a product rule, like too many p's. So on the top, we want to distribute the 7. So we're going to attach that to the -1 and then attach it to the w. And then we still have the z on the bottom. Now, -1 to the 7th power gives you -1. Any negative number that has an exponent that's odd is going to have a negative answer. So that's going to give us a -1 w7 over z to the 7. Or if you want, you can just write it as -w to the 7 over z to the 7. So you can put that negative in the middle if you don't want to make a -1 on top. Now on the right here, we have -2 over a cubed to the 4th. So that negative I can put with the 2. So I can make it -2 over a cubed to the 4th power there. So we want to distribute the 4 to the top of the fraction and then to the bottom. If it already has an exponent, you put it in parentheses. If it has a negative, you put it in parentheses. Make my 3 a little better there. Now on the top, we can do -2 to the 4th power. So since it's an even exponent, we're going to get a positive answer. And my calculator gives me a positive 16 for that. And then on the bottom, you're going to multiply your exponents. I'm not going to write that step now. We're going to just do the multiplication. So you multiply those together. 3 times 4 gives you 12. So you end up with a to the 12. Are there any questions?
No, ma'am.
Okay. So these are basically the major rules that are in 5.2. Probably the hard part is remembering which rule to use when. So I strongly recommend making flashcards or to have like a cheat sheet. The other thing that people struggle with is, how do I know what order to do these rules? So you're going to think of it just like the order of operations. So remember, the order of operations is PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. So your first step is parentheses. So if you have things in parentheses that you can simplify, then you do that first. And that usually means you're either going to do the product rule or quotient rule, which we're covered in 5.1. Once you've simplified all of those things, then you're going to work with the exponents. So if you have an exponent with an exponent, you're going to basically use the power rules where you multiply those exponents together, and then you simplify. Once you've done that, then you're going to be using the multiplication and division rules where you add the exponents. So once you don't have anything left in parentheses, then you're going to use your product and quotient rules to simplify. So that is the suggested order. Doing it in this order usually results in fewer steps, but you can get to the same answer if you do these in other orders. But I find this, it follows the same sort of orders as the order of operations, so it's sort of keeping things consistently. So I'm going to have some examples here where you have multiple rules going on. And so again, I'm going to just write order of operations just as a reminder. So I'm going to work with the first example, the left example, and that is going to be parentheses. Do we have things in parentheses that we can simplify? And that means do I have things in the parentheses that are multiplied together or divided? We have parentheses, but there's only one thing in each set of parentheses. The top has a y cubed and nothing else. The bottom has a y squared and nothing else. So the parenthesis rule doesn't apply here. So we're going to move on to the exponents. And so that means we're going to be multiplying our exponents for the things that have an exponent on an exponent. So we're going to be multiplying those together. So we're going to use the power rules here. So I'm going to keep my y to the 8, and then I'm going to multiply 3 times 4, so that gives me 12. And then in the denominator, 2 times 3 is 6. So I use the power rules. So that's the exponent step. Next is the multiplication step. And so on the top, we have two things that are multiplied together. So our rule for when you have a product is you add the exponents. So we're going to take 8 plus 12, and that gives us 20. So you're going to get y to the 20 over y to the 6th. So we did our multiplication. Now we're going to do the division rule because we have y to the 20 over y to the 6th. So those are divided. And the division rule says you subtract the exponents top minus bottom. So usually for subtraction, people tend to make mistakes, so I like to write it out. So we're going to do 20 minus 6, and that gives you y to the 14. And that's your final answer. So now you've simplified that. So your first step, because we didn't have the parentheses step, was to multiply the exponents together. Then we added the exponents where we could, and then we subtracted them where we could, and that gave us our final answer. Now, the one on the right, it's a little more complicated, but you'll see that the steps are essentially the same. So we start with parentheses. Is there anything in parentheses that we can combine together? We have multiple things inside our parentheses, but none of them can be combined because we have a number, we have something with a C, and we have something with a D. So they're not really considered like because they have different variables. There's nothing we can do there. And the same with the second set of parentheses. We have 3, C, and D. Those we can't really do anything with those. We can't multiply those. So we're going to skip the parentheses step and go to the exponent step. And that is where we're going to distribute the exponent. So this 2 gets attached to the 4, it gets attached to the C cubed, and it gets attached to the D to the 5th. So we're going to have 4 squared. Then we have a C cubed that is squared. And then we have a D to the 5th that is squared. So I'm distributing that outside exponent to everything on the inside. The same thing happens with the other exponent that I have here, this 2. This gets distributed to the 3, the C, and the D cubed. So our 3 gets an exponent of 2, the C gets an exponent of 2, and then our D cubed gets an exponent. So now all of these things are multiplied together. So I can just put a little dot there if we want to indicate that. So we distributed. Now we need to actually simplify those things that have multiple exponents. So we need to simplify all of these items by multiplying those exponents together. So we're still doing the exponent step. And if you want, you can also take the numbers and take care of that too. Like 4 squared, I can do that at the same time. That's 16, because that's also an exponent step. Order of operations, we're just doing all of our exponents. Then I have C, and you multiply 3 times 2, so that's going to be a 6. Then on the D, 5 times 2 is 10. Now I have 3 squared, so that's 9. I have my C squared, and then on my D, 3 times 2 is 6. So that's going to be D to the 6. So now order of operations, I've done the exponent step. Next is the multiplication step. I'm going to just rearrange these things together so you can see just everything we're multiplying together. I'm just kind of grouping them so that it's clear what's getting multiplied together. So number-wise, you can do 16 times 9. So I'm going to need my calculator for that. So that comes out to 144. Now on the C's, when you multiply, you add exponents. And so that's going to be 6 plus 2. So we get 8 as our new exponent. And then on the D, you add 10 plus 6, you get 16. And then we can't simplify that any further because we have different variables that can't be combined in any way. Are there any questions? Okay.
No.
Yeah, I figured I'm giving you plenty of time.
No, that's all right. Yeah, well, I'm good.
Yeah. Now these are my last two, and these are going to be doozies. They look like doozies. They're not as bad as they look. So I wanted to do some that involve fractions as well. So on the left here, we've got a whole bunch of stuff in parentheses. We got x cubed y to the 5th z over 5xy squared. And then that whole thing has an exponent of 2. Then on the right, we have something else very similar, but then it's also multiplied by something else. So again, we're going to be basically following the order of operations here. So first is simplifying inside parentheses. So in this case, we do have things that we can simplify. So we can do the parentheses step because I've got, on the first example, I can simplify my x cubed over x. And I can do that by subtracting the exponents. And then I can also simplify the y to the 5th over y squared by subtracting the exponents. So that's our quotient rule. So we're going to do those first because it just makes things a little bit easier to work with. And when you use that rule and you have fractions, the result always ends up on the top of the fraction. So our x cubed over x, if it has no exponent, you assume it's 1. So that'd be 3 minus 1. So we're going to end up with an x squared on top. The y's, I need to subtract 5 minus 2, which is 3. So that's going to be y to the 3rd. My z is already on top, so it's going to stay on top. And the 5 is in the bottom, so it's going to stay on the bottom. So anything you have to do that subtraction on automatically goes to the top of the fraction. So that's the parentheses step. So we simplified inside the parentheses before we did anything else. The next step is exponents. So I like to do the exponent step pretty much all at once. So I'm distributing that 2 to everything, and I can also do it on the bottom. So when I was showing the quotient rule, I did the top first, then the bottom, and then we used the rule again, but you can basically do it all at once. So that 2 on the outside hits every single thing that I have on the inside. And I find that drawing arrows helps me remember what gets that exponent. So I'm going to have an x squared, which now has a new exponent of 2 on top of that. Then we have a y cubed, which has an exponent of 2. And then our z now has an exponent of 2 since it didn't have one. And then we have our 5, which now has an exponent. Now that I've distributed the outside exponents, now I need to actually multiply the exponents together. And I'm also going to square the 5. So I'm going to take care of those exponents. So you're multiplying 2 times 2, so that's going to be x to the 4th. With the y, 3 times 2 is 6. And then we have z squared. And then 5 squared is 25. Now we're at a point where we're done because we don't have multiple x's anywhere, multiple y's, multiple z's. We don't have anything else that we can really combine together. So this is our final answer. And if you're wondering why you're learning how to do these things, if you're someone that's taking this class and you know that you have to go on a calculus, you're going to need these skills. These skills also come up in college algebra, which is teaching you skills for calculus. So that's why we're hitting these things. And it may look useless right now. You're just taking something with exponents, creating something else with exponents. But it does come in handy once you get to higher level math. So it's a good skill. It's also an important skill that you're learning about how to follow steps and procedures, making sure that you're done. So you're also just learning to pay attention to little details and following the steps and making sure you can complete the steps. So that's a side thing you're learning, even if you're not literally going to be doing this in your daily life. So with that said, moving on to my example on the right, we've got multiple things going on here. And first thing is to try to simplify inside parentheses. So just like on the left, inside my first set of parentheses with the fractions, I have some things that I can simplify by subtracting the exponents because I have an s on the top and the bottom, and then I have a t on the top and the bottom. So I'm going to start by subtracting those exponents. So my s, 5 minus 2 is 3. So I'm going to add s cubed on the top. And then with the t, that bottom has an exponent of 1. We just generally don't write it. 6 minus 1 is 5, so that's going to be t to the 5th. And then I still have this 2 in the bottom. And then I have my exponent. And then I've got this other thing hanging out here. The 10s cubed t squared, that whole thing squared. So that's the parentheses step. Now that there's nothing else in parentheses we can simplify, next is to distribute the exponents. So this 2 is going to be attached to 3 things here. Whoops, went too far. Hit the wrong button. And this 2 is going to be attached to 3 things as well, but they're different things. So you want to make sure you're attaching them to the correct item. So first parenthesis, we have s cubed. That's going to get a square. Then we have t to the 5th, which is also going to get a square. And then in the bottom, we have 2, which is getting a square. Now, I'm distributing again here. Now, because I'm going to be multiplying fractions, and I don't have a fraction, I'm going to just make it a fraction by putting denominator of 1. It's going to make things easier for us. So I have a 10, which is going to get an exponent of 2. Then I have my s cubed, which has an exponent of 2. And then I have my t squared, which has an exponent of 2. But I made that second one a fraction because we're multiplying. We're going to have to multiply these fractions. So now I'm actually going to distribute these exponents by doing the multiplication of exponents step, and also by doing the exponents on the numbers that I can do. So the 10 squared, the 2 squared, that sort of thing. So, and it's really important to make sure that your S's look like S's and not 5s. This sort of looks like a 5 to me. I don't like using the letter S because if I'm not careful, it looks like a 5. But that's what I have here. So I'm multiplying my exponents. So on the S, 3 times 2 is 6. So I have S to the 6. And then on the T, 5 times 2 is 10. And then 2 squared gives me 4. So that's the first fraction. Second fraction, 10 squared is 100. S cubed to the square, you multiply those. That's going to give you another S to the 6th. Then I multiply for the t's, 2 times 2, that's t to the 4th, over 1. So now we're going to multiply these together. We're going to multiply the fraction, and you're going to just multiply straight across. And I'm going to rearrange it so that my numbers are in front. And then I'm grouping my variables together so that it makes it easier when I'm doing the addition step, or where you're adding the exponents, that part. And then 4 times 1 is 4. So now I can do this all in one step. I have 100 over 4. So those actually divide. If it was a fraction, you leave it as a fraction, but 100 divided by 4 is 25. So I'm going to have a 25 there. Now, my s's, you add the exponents. So I'm going to get s to the 12. And then you add the exponents with the t. 10 plus 4 gives you 14. And so we did actually end up with something that is simpler than we started with. In both cases we did. It just kind of depends on what your definition of simpler is. For the one on the left, I can argue either one isn't necessarily simpler, but the one on the right is clearly simpler than we started with. So are there any questions on either of these two examples? I will take that as a no. So that's basically 5.2. So the homework when it says simplifying exponential expressions is basically practicing these rules. 5.3, you learn about negative and zero, which is a separate assignment where you're focusing just on those rules, zero exponents, negative exponents. But this is a good skill just to practice procedures, and if you do have to go on to calculus, it's going to definitely come in handy a lot. But if you don't have to go into calculus, just use this as a practice for paying attention to rules, following things, doing things in the right order, that sort of thing. So that's it. Thank you for joining me on a Friday. We had a couple people that popped in for a little bit and then had to leave. They weren't able to stay the whole time, or I know a lot of people have been having internet issues. So, but I do appreciate that you were able to join on a Friday night. And I'm going to try to, depending on how fast this processes, if it processes quickly, I'll get it out tonight. If not, I'm going to have to make sure that I actually log in to send it out tomorrow. I tend to take Saturdays off, but I want to make sure I send this out to you guys. So it will definitely be out by tomorrow. I'll make sure to email that out and put it in the classroom by then. So thank you so much again. Hope you're staying safe out there, and I will talk to you guys later. Bye.
All right.